The challenges in the microbiology laboratory are many. The contemporary scene of microbiology is putting increased pressure for on-demand testing with an emphasis on decreasing turnaround times for results. We also know that the shortage of clinical microbiologists is one of our most precious resources, and we must be able to identify the value of the microbiology tech to really identify the cases where they can live up to their job description. There are a number of publications that have shown the vacancy rate. This is a study done from 2014 to 2015 data showing about a 6%. We now know that number is much, much higher in contemporary practice, and even within geographical regions where it's very difficult to get qualified laboratory professionals. We also know as laboratory professionals, we have an obligation to provide efficient use of qualified personnel. And if up to potentially 60% of your urine cultures are negative, we need tools that allow us to be able to identify the cases that are likely to have clinical impact and for us to be able to organize laboratory workflow to focus on those cases quicker. So I think it's important that we ask in the clinical spectrum what we're asking our instrumentation to do in the clinical microbiology lab. When it comes to the APAS system, I think it's important for us to remember what the tasks are that we're looking for. So identification of cases that meet criteria for urine culture workup. And really we're asking three questions. Can the system identify cases of no growth and auto-remove those from the workflow? Can it identify cases at greater than 10 to the fourth colony-forming units per mil that we can successfully route to the techs with a degree of high priority cultures? And can it identify cases and enumerate cases of less than 10 to the fourth that we can also route to the techs as a lower priority culture? Importantly, this question is asked, what is the accuracy of the APAS in detecting no-growth cultures? So this is a study of 6,200 clinical specimens performed in our laboratory, of which 1,860 were removed as true no-growth cases, cases that had no growth, no colony-forming units whatsoever on the plate. The APAS was successfully able to remove 30% of our cases from the clinical laboratory workflow, identified as no-growth cases, with 100% agreement with manual clinical interpretation at the bench level. Similarly, a question should be asked, can the APAS correctly enumerate urine cultures and identify cases for review at greater than 10 to the fourth colony-forming units per mil? This is the same clinical cohort of 6,200 clinical specimens submitted to our lab for workup, and the APAS detected these in comparison with clinical technologist bench read. So the metric used was how did the APAS identify and enumerate cases greater than 10 to the fourth compared to what we see with manual tech reads. Overall, there's a 94% agreement as shown in this Venn diagram, 5,828 cultures successfully enumerated over 6,200. You can see on this slide that remains an existing 6%. So let's talk a little bit about this 6%. 2% were identified as cases that resulted in defects in the media. These were scenarios, for example, where the media was gouged or scratched and the camera had a little bit of a difficult time reading them. Additionally, there's also cases in which the label placed on the urine culture plate resulted in a small shadow on the plate that was correctly identified by the APAS system, but that was moved to an error code for the text to elucidate from there. The remaining 4% were detection of colonies by the tech that were not detected by the APAS system. For those of you that have spent time looking at urine cultures, you'll recognize that urine cultures often grow what we call small alpha streptococci. These are small green little colonies of very little clinical significance that typically resemble mixed bacterial flora. In many cases, these colonies were so small that they were not picked up by the APAS system, but when we looked at them with the visual eye, we were able to see them. Importantly, these small alpha streptococci are very rarely clinically significant. So removing those cases provided us with what we call an adjusted percent agreement of 98%, with the remaining 2% really due to variables that are out of the control of the APAS, such as defects in the media of gouges and scratches. So let's review these 4% of cases. Some of you may be worrying, well, I don't want to make sure that my system misses clinically significant cases. So let's delve into this a little bit more with question number 3. What is the impact of 4%? As mentioned, 4% of these small alpha not detected by the APAS system. 0.8% of these were determined to be clinically reportable as Staph saprophyticus. This is Staph saprophyticus that grew at quantitation less than 10 to the fourth. Clinically, there's some debate as to whether or not labs would report these at 10 to the fourth. Our lab does. So there were a couple cases of Staph saprophyticus that didn't enumerate correctly. We also had a couple of cases, 1.2%, that involved the detection of non-beta hemolytic group B streptococci in women of childbearing year at quantitation less than 10 to the fourth. And the APAS identified these as low priority cultures where we would have reported these in our lab. Importantly, it's important to keep in context that these group B streptococci are detected in urine cultures and not group B screening for prepartum and postpartum and prenatal workup. Those in our lab require a separate order for group B screening. So there is a debate here as well about the clinical significance of those cultures. Removing the cases of the small colony variants, however, has an interesting side note to our evaluation. Even though those cases often grow and are reviewed by the tech, they are almost never clinically reported and shown to be clinically significant. So removing those from the workflow as identified by the APAS, removing all those small colony variants actually saved us a cumulative amount of almost 16.5 hours, where the average time it takes for a tech to look at a plate of limited significance was about 4 minutes. And this is a slide just showing you what we can see. And this is really difficult to see, but you can see the significance or the lack thereof of this disconnect that we saw in minor amounts between the tech reads and the APAS. Within each yellow circle is a small colony of alpha strep. And as mentioned before, these are very rarely ever reported as significance in our lab. So I wanted to show you this image so you could put in context what we were seeing with some of the disconnect. So this slide demonstrates Hennepin County Medical Center in the United States, their APAS reporting structure in our laboratory. You can see on this slide, we have on the left column, 4 reporting structures, from positive to negative to technologist review to a 4th category that we've worked with the company to develop that we call Hcmc Doubtful. And we'll run through what these categories mean for you now. A positive case is intuitive. It's a scenario that has greater than 10 to the 4th colony forming units per mil successfully enumerated by the system and or gram-negative growth on the McConkey plate. So any one of those categories will flag as a positive, as will the detection of beta hemolysis on sheep red blood cells. So at any enumeration, as in addition to greater than 10 to the 4th, those cases are successfully identified as positive, and these become our high priority cultures. These are the cases that we feel reporting is warranted and potentially clinically significant, which make up 27% of all of our urine cultures submitted to the laboratory. Second column is also intuitive. It's our negative growth column. And these are cases that have negative growth on the plate. We've set up our system to allow this to auto clear from our workflow. And we see about 30% of our cases that are auto cleared by the system that never come to the bench tech for review because there's no point in spending time on cases that truthfully do not clinically matter. Then we have the cases that are identified by the system that come to the technologist for review as a lower priority category. The first one is cases that have less than 10 to the 4th colony forming units per mil and or swarming on the plate. So this is the contingency to cover for Proteus. It's also the contingency to cover for lower enumerations that you may want to set in your laboratory. For example, you may want transplant to be reviewed by all of the techs in your laboratory at a lower colony forming unit enumeration. So these come to the techs for review. In our lab, this made up about 4% of the cases, which were largely attributed to Proteus. Then we have our final category that we classify as Hcmc Doubtful. These are categories that normally in our lab, we report out as mixed bacterial flora, and we're typically done with them. We don't want to pick through these to provide unimportant clinical information. So these result in cases of less than 10 to the 3rd colony forming unit with no beta hemolysis, no gram-negative growth on the McConkey media. And these are sent as low priority cases, and these are doubtful. After almost 3 years of working with the APAS system, we have enough internal data to suggest that these cases are rarely clinically significant. And we've asked the system to potentially auto-clear both our negative and this doubtful category. This allows us to remove almost 70% of the workflow that is auto-cleared by the APAS in the clinical workflow spectrum, while focusing the techs on the cases that we know are truly informative and truly clinically significant.